Generating a knowledge graph from the Harry Potter book. This is an example of my HumemAI agent, the simplest one, prompt agent, that does text to graph and graph to texts with prompting using a language model. All right, let's start our prompt agent, which is configurable. And in order to visualize the knowledge graph generated, we're gonna run this JNS graph visualizer. And then, okay, now it's gonna start adding nodes and edges, paragraph by paragraph, which looks like this. It's gonna read one by one and generate a graph, and the graph will be there. It's gonna be used as memory to help guide the agent to generate the next graph from the next text. All right, okay, so some are added here. Albus Dumbledore is friend of Severus Snape. Severus Snape is a friend of Ron Weasley. You know what? This is making up stuff. I can feel it because it's hallucinating, because none of these are addressed here in the beginning. So this is what happens when you use a large language model with low parameters. This only has 1 billion parameters. So let's delete all of them, and let's do a bigger model, which typically helps. 8 billion parameter model. Now let's do 3 billion, and with 16 bits. Yeah, let's do 16 bits. Okay. And then let's run this agent again to see how it differs from what it did. Because look at this here, in the beginning there's no mention of whatever this talked about here. Ron Weasley, is it really there? No, it's not, it just made it up. Okay, now let's see, the Sorcerer's Stone, Harry Potter, main character of, well, you don't know that actually, you just guessed it from this first sentence. But it hallucinates far less. I know it because I've already done this before. Harry Potter, the Sorcerer's Stone is a book. It probably doesn't know about that either. Okay, let's see. More graph is generated, being added to the graph. Let's see the CUDA GPU usage here. It's using 8 gigs of, it's using about 6 gigs of memory. Right. Okay, now more stuff on Mrs. Dursley, the son of has mustache. Directs gruntings, makes drills. Okay, yeah, this is pretty accurate. Mrs. Dursley has neck, uses garden, spies neighbors, and these are some vertexes that are identified by the model, by the agent, but doesn't have any connections. All right. So unlike typical large language model, these can run on literally infinite length of text, because everything here is saved in the database, and then the agent is only retrieving what is necessary for the next for generating graph from the next text, and only that part is in the memory. So look at this, and also it shows how many of these vertexes and edges were recalled, how many of them were reused again and again. Agent had to retrieve as a long-term memory for the current given task, which is generating graph from the next text. Okay, gruntings, makes drills. Okay, whoa, more and more. All right. Okay, so this is how it goes. Everything Harry Potter would happen at some point too. All right. Of course, this is a pretty tedious task. It's only done with 10% of the data, and my GPU is not the fastest GPU in the world. It's gonna take a long time. This is only chapter 1. So I will show you. I'm gonna remove all the data and load stuff that I already done. And I can reload into the memory easily, into the database. because it's a simply saved to JSON format. 3.23b. Let's 3.23 3 billion parameter model, 16 bits. Okay, remove all the data. Everything is gone. Load to the database. All right, so this is what happens if you finish running chapter 1. See, Hagrid is saying goodbye to Professor. Yeah. Dudley is thrown at drills. Drills is caused by building. Okay, a lot of random things. So again, it's not perfect. Yeah, so that's the demo. Thank you.